sum and difference rules. We actually used these equations in the past videos, but we didn't explain them fully, so we're just going to write them out today. So say you have one function plus another function. You just take the derivative of the first function and the derivative of the second function and add those together. So let's do that one first. Say you have an equation that reads 7x to the third plus 5. Alright, now let's make these separate. So 7x to the third and 5. We're going to try to find the derivative of this first, and then the derivative of this, and we're going to add them together. So the derivative of 7x to the third, if you remember from the constant multiple rule, is 3 times 7, which is 21, x, and then we subtract 1 from the exponent, so that would be squared, so 21x squared. And remember that the constant rule, since technically you're multiplying this times 1, or x to the 0 power, because remember that equals 1, 0 times 5 is 0, and so, constant multiple rule, any constant turns to 0. So we add these together, these two derivatives, to get 21x squared. So that's the derivative of 7x cubed plus 5. And now let's use the difference rule for deriving an equation. So we're going to do the same thing as we did for the sum rule, but we're just subtracting instead of adding the two derivatives together. So let's do the same equation, but with a minus sign. So 7x cubed minus 5. Alright? But let's change it up a little. Let's do 5x plus 2. So right here, we're going to separate it out into 7x cubed, 5x, and 2. And you can combine these rules. See, like right here, I have a difference rule and a sum rule. So let's derive this, and we get 21x cubed. 21x squared, sorry. Derive this, and we get 5. If we derive this, we get 0. So since we're subtracting f of x from another function, we subtract here. And then over here, we're adding. So this is a sum rule. So if you simplify this, you should get 21x squared minus 5. And that's your derivative.